Good evening. Sorry, I mean only to whichever time zone you are in. Today we're going to talk about research. And by research, I mean research methods and ethics in science. Okay, so the first thing that you have to know is the definition of research. What in itself is research? Okay, so first of all, a search for knowledge. Okay, so that means it's a way of find is research is a way to find answers and learn new things. A scientific systematic search for pertinent information on a specific topic. So that means that you know we use a special way called science to find information that's important and related to what we're looking for. An art of scientific investigation. So this means research is like a special skill or talent that helps us figure things out, just like how you're good at building blocks. Researchers are good at finding answers. And so let's proceed to the definition of research. Okay, and so um, it is defined according to the Advanced Learners Dictionary of Current English. The, it is defined as a careful investigation or inquiry, especially through search for new artifacts in any branch of knowledge. So, um, that is the first way that it is defined. And how do I explain this in simpler terms that can be understood? Okay, so let me proceed with that. This means research is like a special kind of searching, like looking for a hidden toy to find new information, like learning a new language or in any subject. Okay, so imagine a detective searching for clues to solve a mystery. Okay, and then let's proceed to continue. Another definition for research is a systemized effort to gain new knowledge. Okay, so this means research is like a step by step process to learn something new, like learning to ride a bike. Okay, so let's proceed again quickly. The definition research is defined as an academic activity. Okay, so it comprises defining and redefining problems. Okay, so this means research starts with trying to understand what the problem or request is, and maybe even rethinking it to make sure we get it right. Formulating hypotheses or suggested solutions. Next, we try to come up with ideas like guesses that might solve the problem or answer the question. Then we have collecting, organizing, and evaluating data. That is, we gather information like toys in a box, sort it out, and look at it carefully to see what it means. Then we go to making decisions and reaching conclusions. So after that, we use the information we found to make smart guesses like, I think I know the answer, and come to a conclusion like, aha, I was right. And at last, carefully testing the conclusion to determine whether they fit the formulating hypothesis. So we double check our answer to make sure they match our original idea, like making sure the puzzle piece fits. Okay, Then we go to um, the definition of research again can be the manipulation of things, concepts, or symbols for the purpose of generalizing to extend, correct, or verify knowledge, whether that knowledge aids in construction of theories or in the practice of an art. Okay, so let's proceed to explain this definition. Okay, so first of all, this means let's break it down first. It's a long thing, so let's start again and talk about it. The manipulation of things, concepts, or symbols for the purpose of generalizing to extend, correct, or verify knowledge. So this means research is like playing with different things like blocks, ideas, like what's big and red, or symbols like ABC to learn more and make sure what we know is true. Let me proceed. Whether that knowledge aids in construction of a theory or in the practice of an art. So this means we do research to either learn more about how things work, like building a tower, or to get better at doing something, like drawing a picture. Okay. So let's proceed to the definition. Let's continue defining what it is. The term research refers to the systematic method of the term research refers to the systematic method of consistent the term research refers to the systematic method consisting of enunciating the problem. Okay, first enunciating the problem. That means research starts with clearly saying what the problem is, or a question like what's bothering me, or what do I want to learn. Okay, then formulating a hypothesis. So now we make a smart guess, like a hypothesis that's trying to answer the question. I think this might be the answer. Okay, and collecting the facts or data. Then we gather information like choice that helps us figure out if our guess was right or not. Okay, and then analyzing the facts and reaching certain conclusions, either in the form of solutions or you know, towards the concerned problem, or in certain generalizations for some theoretical formulation. So finally, we look at what we found, like counting our blocks, and decide what it means, either solving the problem or learning something new that helps us understand how things work. Okay, so it's like building a bridge with blocks and learning how to make it stronger. The purpose of research is to discover answer answers to questions through the application of scientific procedures. So this means research helps find answers by using specific steps like a recipe that scientists follow to make sure we what we learn is true. Okay, so let's go into the objectives of research. The objective of research is each. Firstly, let's discuss the objective of re of research. Each research has its own purpose. Examples of broad groupings. We have exploratory or formulative research studies to gain familiarity with a phenomenon or to achieve new insights into it. Okay, so this type of research helps us learn about something new or understand it better, like exploring a new playground. And this means we want to know something better or discover new things about it, like learning a new game. And we talk about descriptive research. So this type of research helps us describe something in detail, like drawing a picture of your toy. Yeah, and let's from what you are seeing here is to portray accurately the characteristics of a particular individual situation or a group. Okay, then when if you want to like go into explaining this means we want to describe someone or something truthfully, like writing a story about your family. Okay, then let's talk about diagnostic research. Now, in talking about diagnostic research, it is used to determine the frequency with which something occurs or with which it is associated with something else. So this means that this means we want to count how many times something happens or if it's connected to something else, like seeing how many blocks you stack together. Okay, and like imagine keeping a diary to track your favorite activities. And we have hypothesis testing research. So this type of research helps us to test a smart guess about how things are related, like wondering if blocks make a better tower than Legos. And to test a hypothesis of a causal relationship between variables. Okay, and this means we want to see if one thing affects another, like testing if more blocks make a tower taller. Or imagine doing an experiment to see what makes a ball roll further. Then we have motivation research. Okay, motivation in research. Sorry. So about motivation in research, the questions we are going to look at is what makes people undertake research? Okay, and for this question, there are a lot of answers to it. The first one is desire to get research degree along with its consequential benefits. Okay, some people want to do research to get a specific degree like a PhD and the good things that come with it, like a job or respect. Okay, then also desire to face the challenge in solving the unsolved problems, concern over practical problems, initiates research. Okay, so this what you're going to say is others want to solve problems that haven't been solved yet, like figuring out how to build a tower with blocks. And then we talk about the desire to get intellectual joy of doing some creative work. Some people enjoy doing research because it's like creating something new, like art or making music. Okay, and then we have this fourth one, which is like desire to be of service to society. So people just want to help others or make the world a better place. Other motivation factors, we have desire to get respect or to be respected, and some people want to do research to earn some respect from others. And directives of government, the government sometimes asks researchers to study specific topics like how to make a safer playground. Then we have employment conditions. Some people do research because it's part of their job, and curiosity about new things. Some people are curious and want to learn about new things, and desire to understand causal relationships, social thinking, and awakening. So some people want to research to understand how things are connected and how society works. Let's proceed to discuss the basic types of research. Okay, so this means we're going to go into the types of research, and the first one is descriptive. Sorry, there's descriptive versus analytical. Okay, so imagine you have two boxes to sort your toys into. Descriptive research includes surveys and facts finding inquiries of different kinds. So descriptive research is like a survey that asks questions to understand what's happening now. It's like asking your friends what their favorite game is. Then we have the purpose of descriptive research. The purpose of descriptive research is to describe a state of affairs as it is or as it exists at present. This means descriptive research helps us understand what's happening currently. It's like taking a picture of your toy room to show how it looks now. Now, let's proceed to continue the basic types of research: descriptive versus analytical. The ex post factor research, a term used for descriptive research studies in social science and business research. So ex post factor research is another name for descriptive research in certain fields, and it's like a special name for this type of research. And the researcher has no control over the variables. So in descriptive research, the researcher can't change the things they are studying. It's like observing a toy car rolling down a ramp without being able to stop it. He can only report what's happening or what is going on. So the researcher can only describe what they see or find, like reporting what game you are playing now. Okay, so let's proceed to discuss the basic types of research for descriptive versus analytical. We have the X factor research, and the example we have is the frequency of shopping, preferences of people, or similar data to that. So this means X factor research is used to study things like how often people shop and what they like, or similar information. Okay, and so let's go to the analytical research. So research is like a type of research that helps us understand why things happen or what it means. So it's like trying to figure out why your blocks keep falling down. The researcher has to use facts or information already available to make analysis for a critical evaluation of the material. So in analytical research, the researcher uses existing information to analyze and understand it better. It's like using all your toys to build a new creation, like a castle. Now let's talk about um, the basic type of research, applied versus fundamental. Okay, so applied research aims to find a solution for an immediate problem facing a society or industrial or business organization. So applied research is like trying to find a solution to a problem that's happening right now or in society or in a company. Okay, and the central aim is to discover a solution for some pressing practical problem. So the main goal of applied research is to find a solution to a real world problem that needs to be solved. Okay, and so let's proceed to applied research. The examples we have like research aimed at certain conclusions. Say a solution facing a concrete social or business problem is an example of applied research. So applied research example include studying a specific problem to find a solution. So it's like searching to make how it's like researching how to make a better sandcastle. Okay, and then we go to research to identify social, economic, or political trends that may affect a particular institution. So this type of research helps us understand what's happening in society or business that might affect an organization. Okay, so let's proceed to the basic types of research. The applied research. An example is the copy research to find out whether certain communications will be read and understood. So applied research includes studying whether people will read and understand messages, like whether your friend will read the notes you pass them in class. And the market research or evaluation research is about like applied research, which includes studying how things are selling in the market or evaluating how well something works. So yeah, then we have fundamental research, which is concerned with generalizations and with the formulation of a theory. So fundamental research is like trying to understand how things work in general, like how all toys are made, and using that to come up with a bigger idea. So it's like building a whole city with blocks, not just one house. And then we go to fundamental research. Let's talk about the example, which is research concerning some natural phenomenon or relating to pure mathematics. So fundamental research includes studying things like how nature works or math problems just to understand how they work. Then we have like you can think about like imagine exploring a new park to see what's there. Yeah. And research studies concerning human behavior carried on with a view to make generalizations about human behavior. So fundamental research also includes studying people's behavior to understand how people act in general. So it's like observing um how your friends play together to understand how friendship works. Okay, then we have for the basic types of research, there's quantitative and qualitative. So quantitative research is based on the measure of quantity or amount, and quantitative research is like counting how many toys you have or measuring how tall you are. So it's like using blocks to build a tower and counting how many blocks high it is. And it's applicable to phenomena that can be expressed in terms of quantity. So quantitative research is used when we count or measure something. So imagine weighing yourself on a scale to see how much you weigh. Now let's talk about qualitative research. Okay, so qualitative research is concerned with qualitative phenomena, that is phenomena relating to or involving quality or kind. So qualitative research is like studying what something is like what your favorite toy is and what you like. And imagine like asking your friend why they like a certain game. Okay, and It is aimed at discovering the underlying motives and desires using in-depth interviews for the purpose. So qualitative research tries to understand why people think or feel a certain way by asking them questions. It is like having a deep conversation with your friend to understand what they really think. Let's talk about qualitative research examples. One include investigating the um, reason for human behavior. That is why people think or do certain things. Okay, and then we have the qualitative research. Examples include the studying people studying why people behave in a certain way. So imagine trying to understand why your friend shares their toys with you. This is called motivation research, an important type of qualitative research. So this type of research is called motivation research, and it helps people understand what motivates people. So it's like figuring out what makes you want to play with a certain toy. Now let's talk about conceptual versus empirical. Conceptual research is related to some abstract idea or theory. So conceptual research is like thinking about big ideas or theories, like wondering what's true happiness. Okay, and then imagine dreaming about like a magical kingdom. Yeah. Yeah, and then we talk about like used it is generally used by philosophers and thinkers to develop new concepts or to reinterpret existing ones. So conceptual research is used by thinkers to come up with new ideas or understand old ones. Okay, and it's like building a new Lego puzzle, or finding a new way to use a toy. Let's talk again about the basic types of research. Let's talk about empirical. Empirical research is related to some abstract ideas or theories. Empirical research is like studying something by observing it, like watching how a toy car rolls down a ramp. Imagine playing with Play-Doh to see what shapes you can make. It relies on experience or observation alone without due regard for system and theory. So empirical research focuses on what we can see and experience without worrying much about big ideas. Let's discuss the empirical research. So it is data-based research, coming up with conclusions which are capable of being verified by observation or experiment. So empirical research is like doing experiments or gathering data to support your idea, like building a bridge with blocks to see if it holds. It's like testing a new toy to see if it works. So basic types of this one. So yeah, and then let's try and discuss this part where we talk about empirical research, where the researcher must first provide himself with a working hypothesis or guess as to probable results. Okay, and the researcher starts with a guess about what might happen, like thinking if I build a tall build tower, it might fall. So imagine predicting what game your friend will choose next. Now let's also produce it works to get enough facts or data to prove or disprove um his hypothesis. Okay, and that is all about seeing the researcher collects data to support or disprove their guesses, like counting how many blocks tall the tower is. And it's like gathering toys to build a big castle. Yeah. And then let's proceed to like set up experimental design, which manipulates the person or the material concerned so as to bring forth the desired information. So that means that like the researcher sets up experiments to test their guess, like building a ramp to see how toy cars roll. Yeah. And finally, or for now, we are going to also talk about the other types of research. We have one-time research. The research is confined to a single time period. So one-time research is like taking a snapshot of something at one moment, like a photo or toy collection. And then we have the longitudinal research. The research is carried on over several time periods. So longitudinal research is like taking a video of your toy collection over several periods or weeks to see how it changes. And then the basic types of research, other types of research, you have the field setting research. Field setting research is like studying something in its natural environment, like observing animals in a park. And we have the laboratory research, which is like studying something in a controlled environment, like a science experiment in a lab. Then we have the simulation research. So the simulation research is like studying something using a 10 scenario, like a mock play store to test toys. So all three above depend on the environment, and by this I'm trying to say that they depend on surroundings or environment, like how a toy car works on different surfaces. So if you have a toy car, it won't, the way it will drive on a smooth road is different from how it will drive on a road with potholes. Let's discuss the basic types of research. So we have historical research, which utilizes historical sources like documents, remains, etc., to the philosophy of persons and groups at any remote point of time. So historical research is like being a detective for the past. It's when we use old things like papers, artifacts, and other leftovers to figure out what happened a long time ago. We can even learn about people through thought and believed. We can even learn what people thought and believed back then. And there are two basic approaches to research. Okay, so that means that when we do research, we have two main ways to do it. It's like having two different tools in our toolbox. We have the quantitative research. So quantitative research is like, this approach is all about numbers and facts. It's like counting how many toys you have in your toy box. We use this approach to find answers that can be measured and compared. We have inferential approach. So this is like a special way of using numbers to make educated guesses about something. It's like using clues to figure out what game to play next. Then we have the experimental approach. So this is when we test something to see what happens. It's like trying out a new game to see if it's fun. Then we have the simulation approach. So this is when we pretend to do something to see what might happen. It's like using images to pretend you are a superhero. Then the last one that we have here is the qualitative approach. So for the qualitative approach, this approach is all about words and ideas. It's like reading a storybook to understand what it means. We use this approach to find answers that can't be measured but still make sense. Now let's talk about quantitative approach. So this involves the generation of data in quantitative form, which can be subjected to rigorous qualitative analysis in a formal and rigid fashion. So quantitative approach is like counting toys, and we collect numbers and data, and then we analyze them in a very careful and strict way, like a math problem. Okay, and then we have the quantitative inferential approach. So to form a data based inferential approach, which is to form a database from which to infer characteristics or relationships of a population. So inferential approach is like solving a puzzle. We collect data and use it to make smart guesses about a bigger group, like figuring out what game your friends might like. Then we have the experimental approach. The experimental approach, which is characterized by much greater control over the research environment, and in this case some variables are manipulated to observe their effects on other variables. So the experimental approach is like playing with Play-Doh. We control the environment like a special room, and we test things to see how they change, like mixing colors. And we have the simulation approach, which involves the construction of an artificial environment within which relevant information and data can be generated. So the simulation approach is like building with blocks. We can pretend we can create a pretend world like a toy city to get information and data, like testing a new toy. Then we move on to the what is a simulation. So we are going to break it down. So the term simulation refers to the operation of numerical model that represents the structure of a dynamic process. So the simulation is like a special computer game that mimics real life. It's a way to use numbers and models to understand how things work and make predictions. Okay, and it can be used in building models for understanding future conditions. So simulation helps us build models to imagine what might happen in the future, like blocks to build a future castle. Okay, then we are going to discuss qualitative approach to research. So this one is concerned with subjective assessment of attitudes, opinions, and behavior. So the qualitative approach is like having a conversation with friends. We explore people's thoughts, feelings, and actions in ways that's more like storytelling than counting. So and it uses group interviews, projects and techniques, and depth interviews. So this means that these tools are special way to have conversations and gather information. And for example, we have focus groups are like group chats, and project techniques are like games that help us understand thoughts. Depth interviews are like long cozy conversations. And here too, they are saying all progress is born of inquiry. Doubt is often better than overconfidence, for it leads to inquiry, and inquiry leads to invention. So this means that, and this is by Hudson Maximin, this means that asking questions and wondering about things is what helps us make new discoveries. It's good to ask questions and just think, and not just think we know everything, which is doubt. And that's how we invent new things. And if you look at here, we have research inculcates, and research incorporates scientific and inductive thinking, and it promotes the development of logical habits of thinking and organization. So research helps us think scientifically and logically, like a detective solving a mystery. It helps us organize our thoughts and ideas, like sorting toys into boxes. Okay, and research provides the basis for nearly all government policies in our economic system. So research helps our governments make informed decisions about our country's economy, like a wise leader making choices for the kingdom. And then let's discuss research. Research has its special significance in solving various operational and planning problems of business and industry. So research is like a superhero that helps businesses and industries solve problems and make good plans. And market research is the investigation of the structure and development of a market for the purpose of formulating efficient policies for purchasing products and sales. So market research is like exploring a new playground. We investigate how the market works so we can make smart decisions about what to buy, make, and sell. Then we have operations research, and this one refers to the application of mathematical, logical, and analytical techniques to the solution of business problems of cost minimization or of profit maximization, or what can be termed as optimization problems. So operations research is like using special tools like math, logic, and analysis to help businesses solve problems and make the most profit, spending less. So it's like finding the best way to build a Lego castle. And then we go to research is equally important for social scientists in study source in studying social relationships and in seeking answers to various social problems. So research is like a special tool for social scientists to understand how people interact and find um, solutions to social issues, like a detective solving a mystery. And further significances of research. Um, so for that one, to those students who are to write a master's or PhD thesis, research may mean a careerism or a way to attain a high position in a social structure. So for students working on big projects, thesis research is like a key to unlocking a successful career and achieving a high status in their field. And then we have to professionals in research methodology. Research may mean a source of livelihood, and that is self-explanatory. It's your job. Yes. And then let's proceed to philosophers and thinkers. Research may mean the outlet for new ideas and insights. Okay. And that means that for philosophers and thinkers, research is like a special way to share new thoughts and ideas, like blooming a flower. And to literary men and women, research may mean the development of new styles and creative work. So for writers and artists, research is like a spark that helps them create new stories and writing styles, like a painter with a new brush. And to analysts and intellectuals, research may mean the generalization of new theories. So for analysts and intellectuals, research is like a way to develop new ideas and theories, like building a new castle. Let's talk about research processes. First of all, research methods versus methodology. So in discussing research methods versus methodology, firstly, what you have to note is that research methods are all those methods and techniques that are used for conduction of research. So that's what research methods are, right? And in discussion of this, I can tell you that research methods are like special tools in a toolbox which help us build a project, which is the research, and we use them to collect and analyze data like a puzzle. And then we talk about research methods or techniques refer to methods that researcher uses in performing research operations. So research methods are like recipes that researchers follow to collect and analyze data like baking a cake. They help us find answers to our questions. Then let's continue into discussing research sorry so research methods versus methodology. So research methods are like the individual ingredients or tools we use, right? Whilst the methodology is the whole recipe book and overall plan that shows how to use those ingredients. And then when we talk about research method, they can be put into three groups. We have, in the first group, we include those methods which are concerned with the collection of data. So the first basket has methods that help us to collect new data, like picking fresh flowers. So these methods will be used where the data already available are not sufficient to arrive at the required solution. So what we are saying here is that we use these methods when we don't have enough data to solve the problem, like needing more puzzle pieces. Then when we go on to continue that, the second group consists of those statistical techniques which are used for establishing relationships between the data and the unknowns. So the second basket has special tools, math tools that help us connect the dots between what we know and what we don't know, like solving a mystery. And then the third group consist of those methods which are used to evaluate the accuracy of the results obtained. So the third basket has methods that help us double check our answers to make sure they are correct, like proofreading a story. Then let's talk about a distinction is also made between research techniques and research methods. So we need to separate important things: research techniques and research methods, like separating toys into different boxes. Research techniques refer to the behavior and instruments we use in performing research operations, such as making observations, recording data, and techniques of processing data and the like. So research techniques are like special tools like a microscope or a notebook that help us collect and work with data, like a scientist in a lab. Then we have the research methods, which refer to the behavior and instruments used in selecting and constructing research techniques. So research methods are like the instructions that help us choose and create the right techniques, like creating a Lego castle. So for the type of research, library research, the method of analysis is analysis of historical records, analysis of documents, and the techniques include recording notes, content analysis, tape and film listening, and analysis. Then for the analysis of documents, we have the statistical compilation, um, manipulations, reference, abstracts and guides, and content analysis. Then we go to for field research, the non-participant direct observation is the method. And we do that. The technique is observational behavioral skills, use of scorecards, among others. Then for the participant observation, it's also a type of method in the field research, and that one is for the techniques is interactional recording, possible use of tape recorders, photographic techniques. Then for the another method is the mass observation, which involves recording mass behavior, interview using dependent observers and in public places. And also we have the Mill questionnaire, which is the identification of social, economic background of respondents. Then we have the opinionaire, which is the use of skills, project techniques, and the use of sociometric skills. Then we have the personal interview, which is the interviewer uses a detailed schedule with open and closed questions. Then we have the focused interview, in which the interviewer focuses attention upon a given experience and its effects. Then we have the group interview, which is a small group of respondents are interviewed simultaneously. Then you have the telephone interview, which uses a survey technique for information and for discerning opinion. May also be used as a follow-up of a questionnaire. Then we have the case and study life history. So cross-sectional collection of data for intensive analysis, longitudinal collection of data for intensive character. And then we have the laboratory research. The method is a small group study of random behaviors and behavioral play and role analysis, use of audio visual recordings, use of observers, among others. Now let's proceed to talk about the fact that research methodology is a way to systematically solve the research problem. So research methodology is like a roadmap that helps us find the answers we need step by step, and it may be understood as a science of studying how research is done scientifically. So research methodology is like a set of glasses that help us see how science works and how we can use it to find answers. In it, we study the various steps that are generally adopted by a researcher in studying his research problem, along with the logic behind them. So research methodology helps us understand the steps researchers take to solve a problem and why they make those choices, like following clues. And we were trying to compare research versus research methodology. Okay. And in the act of comparing it, the first thing we said was research methodology has many dimensions. So that means that research methodology is like a diamond with many sides, each one helping us understand research better. Whilst research methods do constitute a part of research methodology. So research methods are like the piece that fits into a bigger puzzle of research methodology. And for research methodology, the scope is wider than research methods, right? And this means that research methodology is like the whole research project, whilst research methods focus on specific tasks. And then we have with research methodology, we consider the logic behind the methods we use in context of our research study and explain why we are using a particular method or technique and why we are not using others. So research methodology helps us choose the best tools and explain why we choose them, like a builder choosing the right hammer. Okay. And then another thing to continue, so that research results are capable for being evaluated either by the researcher himself or by others. So by using research methodology, we make use sure our findings are clear and understandable, like a well-written story. Now let's try to discuss or break down. The scientific method is based on certain basic postulates. So the first one is it relies on empirical evidence. Empirical evidence is like a treasure chest of facts we collect through observation and experiments, and it utilizes relevant concepts. So relevant concepts are like Legos that help us understand and explain what we found. And then we have it is committed to only objective considerations. So objective considerations mean we look at things without bias, like a referee in a game, and it presupposes ethical neutrality. That is, it aims. First of all, let's talk about Its presupposes ethical neutrality. That is, it aims at nothing but making only adequate and correct statements about population objects. So ethical neutrality means we seek truth without agenda, like a journalist reporting facts with no bribe. And then let's talk about the scientific method is based on certain basic postulates. So we are continuing. It results in probabilistic predictions. So probabilistic predictions are like weather forecasts, giving us the likelihood of something happening. And then we have its methodology is made known to all concerned for critical scrutiny, for use in testing the conclusion through replication. So what we are trying to say here is that we share our method so others can check and repeat our work, like sharing a recipe. And it aims at formulating most general axioms, or what can be termed as scientific theory. So scientific theories are like maps that help us understand the world, and we strive to make them as accurate and broad as possible. Now let's discuss the importance of knowing how research is done. So knowing research methods is like having the right tools for your toolbox, so you can fix things and build new things. And that's why they are saying the importance of knowing research methodology and research is to know the tools of his trade. And when we go to B2, so learning research methods is like getting a new pair of glasses that help you see the world in a new way and make sense of things happening around you. So knowing how research is done gives one the satisfaction of acquiring a new intellectual tool, which can become a way of looking at the world and of judging everyday experiences. And for this part two, critical thinking. Knowing research methods help you judge if research are trustworthy, like checking if a bridge is safe to cross. Okay, so that's why they are saying knowledge of how to do research will inculcate the ability to evaluate and use research results with reasonable confidence. In this, in with reasonable confidence. So let's talk about this D, which is saying that informed decisions, right? We all use research findings in our daily lives, and knowing research methods help us make informed decisions, like choosing a good school for your education. So that's what they are saying here, that in this scientific age we are all consumers of research results, and we can use them intelligently provided we are able to judge the adequacy of the methods um by which they have been obtained. And then finally, what we are saying here too is that research process is like a recipe with many steps, like mixing and baking, decorating a cake. You need to follow the right order to get the best results. So that's what they are saying here, that research consists of a series of actions or steps necessary to effectively carry out research, and the desired sequencing of these steps. And this is the research process on a flowchart. First, you define the research problem, then you review the literature, review concepts and theories, review process and research findings, formulate hypotheses, design research including sampling design, collect data, execution, analyze data, into brackets, test hypothesis if any, interpret, and report. So where F is feedback, which helps in controlling the subsystem to which it is transmitted, and FF is feed forward, serves the vital function of providing criteria for the research. Okay, and so let's try to talk about the chart, right? So the chart indicates that research process consists of a number of closely related activities as shown through I to BI. And the first step determines the nature of the last step to be taken. If subsequent procedures have not been taken into account in the early stages, serious difficulties may arise, which may even prevent the completion of the study. So, planning ahead, if we don't think about what's coming next, it's like building a house without a blueprint, it might not work out. Useful procedural guideline regarding the research process. The procedural guidelines regarding the uh, research process are the first one is formulating the research problem. Formulating the research problem is like asking the question, what's the best way to make cookies? And we have extensive literature survey, and with this one is like reading all the books, cookbooks, to see what others say about making cookies. And you have developing the hypothesis, which is thinking maybe if I add nuts, my cookies will be the best. Then preparing the research design, which is like deciding how to test your um, cookie recipe. Then you have the determining sample design, which is like choosing what gets to who gets to taste your cookies and judge them. Then we move on to collecting data. So collecting data is like gathering the ingredients for your cookie recipe. Execution of the project is like mixing and baking your cookies. Analysis of data is like tasting your cookies and deciding what works and what doesn't. And then we have the hypothesis testing, which is like trying to understand different ingredients to see if your idea about nuts was right. Then you have the generalization and interpretation, which is like realizing that what you learned about cookies can help other recipes too. Then we have preparation of the report or the presentation of the results. That is formal write-up of the conclusion reached. So step 11 is like writing a cookbook with your new recipe and sharing it with others. Then we have description of the research process, formulating the research problem. So formulating the research problem is like asking a question about the cookies. How can I make the best cookies? And there are two types of research problems. We have those which relate to the state of nature, which is some research problems are like observing how cookies naturally turn out, and we have those which relate to relationships between variables. So some research problems are like finding out how different ingredients affect cookie texture. Then we have formulating the research problem. Formulating the research problem, so we are talking about um we are still under formulating the research problem. And first, the next thing is the feasibility of a practical solution to a research problem has to be considered before a working formulation of the problem can be set up. So before we dive into the problem, we need to think about whether our idea for a solution is even possible, like checking if we can have all the ingredients. Then we talk about the formulation of a general topic into specific research problems constitutes the first step in scientific inquiry. So we take a broad topic, narrow it down to a specific question, like going from baking to best cookie recipe. Then the two steps are involved in formulating research problem. We are talking about understanding the problem thoroughly, which involves we need to fully understand what we are trying to solve, like knowing what makes a cookie great. Then we have rephrasing the same into meaningful terms for an analytical point of view. So we rephrase the problem in a way that helps us analyze it, like rewriting a recipe in our own words. And then we talk about formulating the research problem. We are also going to continue talking about the researcher must examine all available literature to get acquainted with the selected problem. So we need to read all about the topic, like reading a book about the treasure we are searching for. Then review two types of literature. So we have two types of books like to read, like fiction and non-fiction. So the first one is the conceptual literature concerning the concepts and theories, and we read about ideas and theories like learning about the treasure map. Then we have the empirical literature, which consists of studies made earlier which are similar to the one proposed. So we read about what others have found, like reading about hunters and other treasure hunters adventures. And then let's proceed to talk about the extensive literature survey. So the literature survey is like searching for clues in books you've read. Then we have the formulated research problem must be written down in a brief summary. So we write a short summary of our question, like writing a note about the treasure we are seeking. It is compulsory for a research worker writing a thesis for a PhD to write a synopsis for the topic and submit it to the necessary committee or research board for approval. So if we are writing a big thesis, we need to write a short version of our question and get it approved, like getting permission to search for treasure. Then let's talk about extensive literature survey. Okay, so the literature survey is like a treasure hunt in the library. The researcher should undertake extensive literature survey connected with the problem. So we need to search widely for books and articles related to our question, like searching for clues to find the treasure. Then we have the abstracting and indexing journal and published or unpublished bibliographies are the first place to go. So we start with special books that list other books and articles, like a map to the treasure chest. Then we talk about depending on the nature of the problem. Academic journals and conference proceedings, government reports, books, etc. must be tapped. So we look for different types of books and articles, like different parts of the treasure. Then we have extensive literature and survey. Literature survey. So the literature survey is like following a trail of breadcrumbs to find the treasure. So in literature review, one source will lead to another. So each book or article leads us to another, like following a chain of clues. And earlier studies, which are similar to the study in hand, should be carefully studied. So pay attention. Um we need to carefully read studies that are similar to ours, like studying a map to avoid getting lost. And we talk about development of working hypothesis, right? And for this part, um now we make a smart guess, like a hypothesis, to guide our research. So after extensive literature survey, researcher should state in clear terms the working hypothesis or hypotheses. And here, after reading all these books and articles, we write down our hypothesis like writing a note to ourselves. Then, working hypothesis is tentative assumption made in order to draw out and test its logical or empirical consequences. So, our hypothesis is like a prediction that will test, like checking if our treasure map is correct. Then we talk about the development of working hypothesis. So our hypothesis is like a flashlight that helps us on focus our research. Okay, so hypothesis should be very specific and limited to the piece of research in hand because it can be tested. So our hypothesis must be clear and specific, like a precise map of the treasure. And the role of hypothesis is to guide the researcher by delimiting the area of research and keeping him on the right track. So our hypothesis helps us stay on track like a compass pointing us in the right direction. Here's what we are talking about. Let's talk about development of working hypothesis. So first of all, our hypothesis is like a treasure map that helps us find answers, right? And it sharpens his thinking and focuses attention on the more important facets of the problem. So our hypothesis helps us think clearly and focus on the important things like a magnifying glass that helps us see the details. So it also indicates the type of data required and the type of methods of data analysis to be used. So our hypothesis guides us on what information we need and how to analyze it, like a recipe that tells us what ingredients to use and how to mix them. Development of working hypothesis, the approach. So now we are going to make our hypothesis even stronger. Okay, so the first thing that we are going to do is discussion with colleagues and experts about the problem, its origin, and objectives in seeking a solution. So this one is about teamwork. We talk to others who know about the problem, like asking a friend for help with a puzzle. Then examination of data and records, if available, concerning the problem for possible trends and peculiarities and other clues. So we look at the information we have like clues in a mystery to help us solve the problem. Then we talk about C, which is review of similar studies in the area of the studies on similar problems. So we read about other studies that are similar to ours, like reading a book about a similar adventure. Then we have exploratory personal investigation, which involves original field interviews on a limited scale with interested parties and individuals with a view to secure greater insights into the practical aspects of the problem. So this is like field trip. We talk to people involved in the problem, like asking a tour guide about the terrain. Then we discuss summary, development of working hypothesis. Okay, so how do we make a working hypothesis? Working hypothesis arise as a result of so thinking ahead. We say a priori thinking about the subjects. So that is brain power. We think deeply about the topic. Then examination of the available data and material, including related studies and So before we go to the end, down this one is about researching again, and we look at the information. We look at all the information we can find. Then we have the council of experts and interested parties. So this one is teamwork. We ask for help from people who know a lot. Then we talk about preparing the research design. So the research problem having been formulated in clear-cut terms, the researcher will be required to prepare a research design. We have our question now. We need a plan to answer it. So preparation of design facilitates research to be as efficient as possible, yielding maximal information. So our plan helps us get the most information with the least effort, like a shortcut to treasure. Then preparing the research design. So our plan is like a map to the treasure. The function of the research design is to provide for the collection of relevant evidence with minimal expenditure of effort and time. So our plan helps us collect the right information without wasting time or resources, like a wise adventurer. Considerations for the preparation of research designs. So now we are planning our research design like a blueprint for our adventure. The means of obtaining the information. So we need to decide how to get the answers, like choosing the right tool for the job. The availability and skills of the researcher and his staff. So teamwork. We need to think about who helps us and what skills they bring, like a team of superheroes. And then we talk about explanation of the way in which selected means of obtaining the information will be organized and the reasoning leading to the selection. So we need to explain why we chose our method and how we will use it, like a recipe for our research. Then we talk about the time available for research, which is all about needing to think about how much time we have, like a timer on a treasure hunt. Then we go into the cost factor relating to research, that is the finance available for the purpose. So we need to think about how much money we have, like a piggy bank for our research. Then determining sample design. Now we are choosing who or what to study, like selecting the right puzzle. All the items under so all the items under consideration in any field of inquiry constitutes a universe or population. So our universe is like a big box of toys and our population is like all the toys inside. Then a complete enumeration of all the items in the population is known as the census inquiry. So a census is like counting all the toys in the box one by one. And in practice, the slightest element of bias in such an inquiry will get larger and larger as the number of observations increase. So if we are not careful, our answers might get more and more wrong, like puzzles with missing pieces. So accuracy matters. Determining the sample design. So now we are choosing a smaller group from our universe to study, like selecting a few toys from the box. So there is no way of checking the element of bias or its extent except through a resurvey or use of sample checks. So we need to be careful about bias, like making sure our puzzle pieces fit correctly. The researcher must decide the way of selecting a sample as in sample design. So we need to decide how to choose our smaller group, like a recipe for our research. And a sample design is a definite plan determined before any data are actually collected for obtaining the sample from a given population. So that's like the blueprint. Our sample design is like a map to find the right choice in the box. And determining the sample design. Now we are learning about types of samples, like different ways to play with our choice. So samples can be either probability samples or non-probability samples, right? And in talking about that, um, we have two types of samples, like two different games to play. With probability samples, each element has a known probability for being included in the sample. So a fair chance. In probability samples, each toy has an equal chance of being chosen, like a lucky dip. And we have the non-probability samples, which do not allow the researcher to determine this probability. So like there are no guarantees. So in non-probability samples, we can't be sure which toys will be chosen, like a surprise party. Determining the sample design. So now we are learning about different ways to choose our sample design, like different games to play with our toys. Then in the talking about this, we talk about probability samples based on um first of all, probability sample based on is like fair chance. So probability samples give each toy an equal chance for being chosen, and simple random sampling is like randomly picking toys from the box. Systematic sampling is like picking every third toy from the box. Stratified sampling is like dividing the toys into groups and picking some from each. And we have cluster or area sampling, which is like neighborhoods. So cluster or area sampling is like picking all the toys from a few neighborhoods. Then for the non-probability samples like is like they don't give each toy an equal chance of being chosen. So we have the convenience sampling. Convenience sampling is like picking the toys that are easiest to reach. Judgment sampling is like letting a toy expect pick the toys or pick the samples. And quota sampling technique is like dividing the toys into categories and picking from each. Let's discuss importance of sample design. So now we are learning about the special types of sample. Let's talk about important sample designs, and let's talk about the deliberate sampling. And deliberate sampling is like purposively picking the toys that best represent the whole box, and this is known as purposive or non-probability sampling, and it is um like on purpose. And deliberate sampling is like choosing the toy on purpose and not by chance. It involves purposive or deliberate selection of particular units of the universe for constituting a sample which represents the universe. So representation, that is deliberate sampling, helps choose toys that represent the whole universe, like a mini box of toys that shows what the whole box is like. Okay, so let's talk more about deliberate sampling again. So convenience sampling is when convenience sampling is like picking toys that are easy to reach. When elements are selected for inclusion in the sample based on the ease of access. So nearby, we choose toys that are nearby, like picking flowers from the closest garden. And the example is like, let's say we want to know what people think about a new toy. So a researcher wishes to secure data from gasoline buyers. He might select a fixed number of petrol stations and may conduct interviews at those stations. And then, so like This one is like, let's talk about like filling up. We might choose a few gas stations and ask people what they think while they are filling up the tanks. And then we discuss important sample designs. um let's continue with the deliberate sampling. We have judgment sampling. So judgment sampling is like letting a toy expert choose the toys. The researcher the researcher judgment is used for selecting items which he considers as representative of the population. So expert choice, we use our expertise to choose toys that represent the whole box. And let's say we want to know what college students think about a new way of learning. So a judgment sample of college students might be taken to secure reactions to a new method of teaching. So we might choose a few college students and ask them what they think about a new way of learning. And the important sample designs, we have the simple random sampling, which is then for simple random sampling, it's like a lucky dip where each toy has an equal chance of being chosen. So this type of sampling is known as chance sampling or probability sampling. So like a fair chance, it's like each toy has a ticket in a lottery and each ticket has an equal chance of being drawn, where each and every time in the every item in the population has an equal chance of inclusion in the sample. So equal opportunity. Each toy in the box has the same chance of being chosen for our sample, and each one of the possible samples has the same probability of being selected in case of finite universe. And then we go to the same odds. If we have a finite number of toys, each possible sample has the same number has the same chance of being chosen. So let's say that example. So we want to choose a few toys from a big box. So we have to select a sample of 300 items from a universe of 15,000 items. Then we put the names or numbers of all the 15,000 items on slips of paper and conduct a lottery. So it's like a lucky draw. We draw all 15,000 toy names, then put them in a hat and draw out 300 names for our sample. So it's like a toy lottery. And let's talk about systematic sampling. For systematic sampling, it's like picking every 10th toy from a shelf. So systematic sampling is to select, for example, every 15th name on a list, every 10th house on one side of a street, and so on. So yeah, it's like a pattern which we choose toys at regular intervals, like every fifth toy. So in such a design, the selection process starts by picking some random points in the list, and then every nth element is selected until the desired number is secured. So it's like a starting point. We begin at a point, as a random point, then close every nth toy we have until we have enough. And yeah, so let's talk about stratified sampling. So for stratified, it's like we are learning about stratified sampling, like sorting toys into categories. So if the population from which a sample is to be drawn does not constitute a homogeneous group, then stratified sampling technique is applied so as to obtain a representative sample. So if toys are different types, we use stratified sampling to get a mix. and the population is stratified into a number of non-overlapping subpopulations or strata, and sample items are selected from each stratum. Yes, and we do this like about sorting, where we divide our toys into groups, then choose some from each group to get a representative sample. Now let's try to discuss what quota sampling is about. So quota sampling is like giving a toy collector a list of toys to find without choosing the exact toys. So in stratified sampling, the cost of taking random samples from individual strata is often so expensive that that interviewers are simply given quota to be filled from different strata, the actual selection of items for sample being left to the interviewer's judgment. So it's like efficient. Instead of randomly choosing toys from each group, we give the collector a list of how many toys to find from each group. So that is what quota sampling is about. So quota sampling is like a treasure hunt with a list in simplest terms. And then let's talk about cluster and area sampling. So now we are learning about cluster and area sampling, like grouping toys by theme. And cluster sampling involves grouping the population and selecting the groups or the classes rather than individual elements for inclusion in the sample. So it's like clusters. We group our toys into themes and choose a few themes to represent the whole box. And that's what we are doing. Then let's discuss cluster and area sampling. So um let's say a store wants to know what their credit card holders think, right? Suppose some departmental source wishes to sample its credit card holders. It has issued its cards to 15,000 customers. That's a big list. The store has a list of 15,000 credit card holders, and the sample size is kept to, let's say, 450. So it's like a smaller group, and we want to choose 450 card holders to represent the whole list. For cluster sampling, this list of 15,000 cards could be formed into 100,000 clusters of 150 card holders. So that's grouping. We divide the list into 100 groups of 150 card holders. Then we have the three clusters might be selected for the sample randomly. So we choose the three groups randomly to represent the whole list. Then we have collecting data. So now we are learning about collecting data, which is like gathering toys in a basket. So there are several ways of collecting the appropriate data, and we have different ways to collect different games to play, and they differ in context of money, cost, time, and resources at the disposal of the researcher. So it's like planning. We choose the way that fits our budgets and resources, like choosing the right game for our party. And in collecting data, we are learning about gathering toys in a basket, right? So primary data can be collected either through experiments or through survey. So we can collect data by trying something new, which is an experiment, or by asking some people questions, which is a survey. So if the researcher conducts an experiment, the observer and he observes some quantitative measurements or the data, with the help of which he examines the truth contained in his hypothesis. So we try something new, measure what happens, and see if it supports our idea. Data collecting by survey. So now we are learning about surveys, like asking friends about their favorite toys, and we talk about like by observation. So we can collect data by observing like watching how people play with toys. And this method implies the collection of information by the way of investigators' own observation without interviewing the respondents. So it's like watching. We calculate data, we collect data by watching what people do without asking them questions, no questions asked. And this method is not suitable in inquiries where large samples are concerned. And here that means that observe this is for small scale, and observing is better for small groups but not for big crowds. Then we talk about data collection by survey, where we are learning about surveys like asking friends about their favorite toys. Then we are still on that, so like through personal interview, right? And we can collect data by asking questions in person, like a friendly chat. So the investigator follows a rigid procedure and seeks answers to a set of preconceived questions through personal interviews. So we ask questions in a specific order, like a fun questionnaire. So this method of collecting data is usually carried out in a structured way where output depends upon the ability of the interviewer. So the person asking the question needs to be good at it, like a skilled toy builder. And through telephone interview. So now we are learning about phone interviews, like calling a friend to chat, right? And this method of collecting information involves contacting the respondents on telephone itself. So phone call, we ask questions over the phone, like a toy phone conversation. And it is important when the survey has to be accomplished in a very limited time. So phone interviews are great when we need answers fast, like a speedy toy delivery. Then we talk also about number four, which is num emailing of questionnaire, right? And for email of questionnaire, this just talks about how you can collect data by questionnaires in the mail, like sending a letter to a pen pal. And the researcher and the respondent do not come in contact with each other in this method of survey adopted, which is self-explanatory. And the questionnaires are mailed to the respondent with requests to return after completing the same. So we send questions and they mail back answers, like fan mail exchange. Okay, and then we talk about collecting data. So we are learning about collecting data, like gathering toys in a basket, and the researcher should select one of these methods of collecting data, taking into consideration the nature of investigation, objective and scope of inquiry, financial resources available, time, and desired degree of accuracy. So it's like planning. We choose the best way to collect data, like choosing the right game for our party, considering what we want to know, how much time and money we have, and how accurate we need to be. Analysis of data. So now we are going to learn about analyzing data. What like sorting toys into categories. So after the data have been collected, the researcher turns to the task of analyzing them. After we collect data, we start analyzing it, like solving a puzzle. The analysis of data requires a number of closely related operations, such as establishment of categories and application of these categories to raw data through coding and tabulation, and then drawing statistical inferences. So it's like sorting. We categorize data, like sorting toys into bins and then using codes and tables to understand it better. And we talk about hypothesis testing. Now we are learning about testing hypothesis, like trying a new game. So after analyzing the data, the researcher is in a position to test the hypothesis he had formulated earlier, if any. And testing time. So this is about like the testing time. So after analyzing the data, we test our ideas like a new toy. And then we talk about hypothesis testing will result in either accepting the hypothesis or rejecting it. So we see if our idea is right or not, like a game of true or false. And so if the researcher had no hypothesis to start with, the generalization established on the basis of the data may be stated as hypothesis to be tested by subsequent researchers in times to come. So it's like new ideas. If we didn't have a specific idea to test, we might find new ideas in our data, like discovering a new treasure or like a new toy or something. And then we go to preparation of the report or the thesis. So now we are planning about writing a report, like a story. And writing of a report must be done with great care, keeping in view the following. We need to be careful when writing our reports, like building a tower with blocks. The layout of the report should be as follows. We have the preliminary pages, the main text, and the end matter. Okay, and so this is like the structure. Our report needs to have a beginning, which is the preliminary pages, a middle, main text, and the end, which is the end matter, like a story with a start, middle, and end. In its preliminary pages, the report should carry um, title and date, followed by acknowledgement and forward. So our report starts with a title, the date, acknowledgement, like thanking friends for help, and a forward, like an introduction for a book. Then let's discuss preparation of the report or thesis. Okay, so now we are planning about writing a report like a story. Then um then there should be a table of contents followed by a list of tables and list of graphs, if any, given in the report. So organization, we need a table of contents, like a map of our report, list of tables and graphs, like a list of toys we use. And then we go to the main text of the report should have the following parts. So we are going to talk about the parts that it should have, and the first one is the introduction. It should contain, so the introduction is like the beginning, and our report starts with an introduction, like a welcome sign. So it should contain a clear statement of the objectives of the researcher and an explanation of the methodology adopted in accomplishing the research. So this one is like explanation, so where we explain what we wanted to find out and how we did it, like telling a friend about our adventure. Then we talk about the scope of the study, along with various limitations as well, should be stated in this part. So this is where we explain what our study covered and what it did, like showing a friend what's inside and outside our toy box. Then we have the summary of findings. So next comes the summary of findings of what we found. We are going to talk about the summary of what we found out. So after introduction, where there would appear a statement of findings and recommendations in technical language, right? So that is just saying that, like, simple language. We explain what we found in simple terms, like telling a friend what we discovered. If the findings are extensive, they should be summarized. So this is like shorter version. If we found a lot, we summarize it, like making a short list of our favorite toys. Then we talk about preparation of the report or thesis. So we are proceeding with that again. We go to the main report, which is the main part. The main body of our report comes next, like the middle of our story. And the main body of the report should be presented in logical sequence and broken down into readily identifiable sections. So organization, we organize our reports in a logical order, like building with blocks, and break into clear sections like chapters in a book. And then we talk about like the conclusion. So next comes our conclusion, like the end of our story. And towards the end of the main text, researchers should again put down the results of his research clearly and precisely. So that's like the summary, where we summarize our findings again, like a quick recap of our adventure. And it is the final summing up. So that's the final words. Our conclusion is our final thought, and like the last page of our book. And at the end of the report, appendices should be enlisted in respect to all technical data. And that's like extra details. We add extra details like technical data at the end, like a bonus chapter. Then we go to the bibliography, which is a list of books, journals, and reports, etc., consulted, should also be given in the end. So these are like the references. We list all sources we use, like a list of our favorite books. Then we talk about the index. The index should also be given, especially in published reports, in a published report. So we add an index, like a map, to help others find specific parts of our reports. Now let's proceed, where we talk about how the reports should be written in a concise and objective style, in simple language, avoiding vague expressions like "it seems," "there may be," and like stuff like that. So like clear writing, we write our report in simple language without vague words, like telling a friend what happened. Charts and illustrations in the main report should be used only if they present the information more clearly and forcibly. Okay, so pictures, we add charts and illustrations only if they help explain our points better, like showing a picture of our favorite toy. So the picture should have a function there. It's not just anything that you are using to decorate it. Then we also going to talk about calculated confidence limits. Calculated confidence limits must be mentioned, and various constraints experienced in conducting research operations may as well be stated. So this is like details. We include important details like confidence limits and any challenges we face, like telling a friend about our adventures, ups and downs. Criteria of good research. So for the criteria of good research, we are learning about good research, like building a strong tower. So the purpose of research should be clearly defined and common concept be used. Okay, and so it's like we have to have a clear goal. We define our research goal clearly, like setting a target, and use common concepts like sharing toys with friends. And then the research procedure used should be described in sufficient detail to permit another researcher to repeat the research for further advancement, keeping the continuity of what has already been attained. Okay, so we explain our research, so it's like sharing steps, and we explain our research steps clearly, like sharing a recipe, so others can build upon our work. So when you make your own research, your aim is not just to just have your research there. Your aim is to have a research that can be continued till, like, it's just supposed to be um something that can be taken up by another person to even improve and make it better. And the criteria of a good research, let's continue with that. We have the procedural designs of the research should be carefully planned to yield results that areas that areas objective as possible. So this is about like careful planning. We plan our research carefully to get unbiased results, like building a tower in a steady base, where the steady base is the unbiasedness of the results. And then we talk about the research, how the researcher should report with complete frankness, flaws in procedural design, and estimate their effects upon the findings. So it's like honesty, we share our mistakes and how they affected our results. Like a friend telling a friend about our wobbly our tower's wobbly parts. Or it's like if you're talking about for example in the tower, you can like you've built a tower. Yes, you have to be honest about maybe some things that you couldn't get. Maybe we couldn't get the rods that we needed for the tower, so it's not perfectly stable. So when you are coming into this tower, be aware of that. So that's the same thing. It's like in the research, you just talk about the things that you couldn't really get perfectly, which makes the research maybe not fully perfect, but still can be used for analysis. Yeah, and then we talk about um the analysis of data should be sufficiently adequate to reveal its significance, and methods of analysis should be appropriate. So this is like data analysis, right? We use the right methods to analyze our data and make sure it's good enough to show what's important, like counting blocks to build a strong tower. And the validity and reliability of the data should be checked fully. So this is like a data check. We double check our data to make sure it's accurate and trustworthy, like making sure our blocks are steady. Then we talk also about the conclusion. So conclusions should be confined to those Conclusions should be confined to those justified by the data of the research and limited to those for which the data provided an adequate basis. So data-based conclusions, we only draw conclusions that our data support, like a tower, like building a tower only as tall as our blocks allow. Don't try to build castles in the air. Then let's proceed to the greater confidence. Greater confidence in research is warranted if the researcher is experienced, has a good reputation in research, and is a person of integrity. So we have trustworthy researcher. We trust research more when the researcher is experienced, has a good reputation, and is honest, like a friend who always shares their toys. So just even if your research is not fully perfect and maybe you had some flaws, just being honest about it puts you ahead. Let's discuss research design. So research design is the arrangement of conditions for collection, analysis of data in a manner that aims to combine relevance to the research purpose with economy in the procedure. So we are learning about research design, which is like building a new playground. And the first part is like the research plan. So our research we organize our research to collect and analyze data in a way that's relevant to our question and use resources wisely, like building a playground with the right equipment. And the research design is the conceptual structure within which research is conducted. So it's like the framework. Our research design is like a blueprint that guides our research, like a map to build a playground. And it constitutes the blueprints for the collection, measurement, and analysis of data. So our research design helps us collect, measure, and analyze data, like building a playground with a plan for swings, slides, and fun. Design decisions happen in respect of. So here we are going to talk about when we are making decisions about our research, like let's say planning a birthday party. What's the study about? So that's like what's the theme, like the theme of the party. We define our research, we define what our research is about, like choosing a theme for a party. What's the study being made? Why is the study being made? So why are we celebrating? The reason for the party. We determine the purpose of our research, like why we are throwing a party. And where will the research be carried out? So where is the party? We design where our research will take place, like choosing the venue for our party and what type of data is required. So what games do we need? Games at the party. We identify what type of data we need, like choosing games for our party. And where can the required data be found? So where are the toys? Toys for the games. We find out where we can get the data we need, like finding toys for our party games. And what periods of time will the study include? So this means when is the party? Schedule of the party. We decide on the time for our research, like scheduling a party. So what would be the sample design? That is who is invited, like the guest list. We choose our sample group, like creating a guest list for our party. And what techniques of data collection will be used? That's how do we play, like the game rules. We select the method to collect our data, like deciding how to play our games and how will the data be analyzed. That's how do we keep score, that's score keeping. So we determine how we'll analyze our data, like keeping score at our party, and what style will be reported, will be the report be prepared, in what style will the report be prepared. So that's how do we share photos, sharing party photos. So we decide on the style of our research report, like sharing photos from our party. And then split the overall design into the following parts. It's like the research plan. So we are dividing our research plan into smaller pieces, like separating toys into different boxes. So the sampling design, which deals with the method of selecting items to be observed for the given study. So it's like who's in the game, choosing players. We decide how to choose the people or things we want to study, like picking teammates for a game. Then the observational design, which relates to the condition under which the observations are made to be made. So that's like where is the playground? Choosing a play area. So we determine the conditions for our study, like choosing a safe place to play. Then we go into the statistical design, which concerns with the question of how many items are being observed and how the information and data gathered are to be analyzed. So how many toys do we need? That's counting toys. We figure out how many things we need to study and how to analyze our data, like counting toys and keeping track of scores. And the operational design, which deals with the techniques by which procedures specified in the sampling, statistical, and observational design can be carried out. So it's like how do we play? playing together, and we plan how to put our research plan into action, like working together to build a sandcastle. Yes, so we go into the important features of research design, right? And the important features of research design is all about, we are learning about the important parts of our research design, like different colors of a rainbow. So it is, first of all, it is a plan that specifies the sources and types of information relevant to the research problem. So what's the question? So it's like asking a question, and we identify what information we need to answer in our research question, like finding the right puzzle piece. And then it is also a strategy, it is a strategy specifying which approach will be used for gathering and analyzing data. So how do we play? That is like choosing a game, and we decide how to collect and analyze our data, like choosing a game to play. Also, it's also includes the time and cost budget, since most studies are done under these two constraints. So how much time and money, which is like setting up a budget. We plan how much time and money we need, like setting a budget for a toy purchase. And yeah, let's proceed to research design must contain the following. So we are making sure our research plan includes all the necessary parts, like a checklist for a treasure hunt. The first one is a clear statement of the research problem. So what's the mystery? Defining the mystery. We clearly state what we want to solve, like defining the mystery we want to solve. Then B, procedures and techniques to be used for gathering the information. So how do we search? Like it's about like finding clues. We decide how to gain information, like finding clues in our treasure hunt. Then C, the population to be studied. So who's in the game? We identify who or what we want to study, like choosing teammates for a game. And then the methods to be used in processing and analyzing data is like, how do we solve it? So it's like solving the mystery. We plan how to analyze our data, like solving the mystery with our clues. And the need for research design is where we are learning why we need a research design, like a map to guide us on a fun adventure. And research design is needed because it facilitates various research operations to progress smoothly. So it's like a roadmap. Our research design helps us move forward smoothly, like following a map to a treasure chest, and it makes research as efficient as possible, yielding maximal information with minimal expenditure of effort, time, and money. So efficient research. Our research design helps us get the most information while saving time, money, and effort, like finding the shortest path to a yummy ice cream truck. Then we have research design, time, and money. And research design stands for, so research design stands for advanced planning of methods to be adopted for collecting the data, for collecting the relevant data, and techniques to be used in their analysis. So that's like planning ahead. We are planning our research design like a blueprint for a building, for building a Lego castle, and keeping in view the objective of the research and the availability of staff, time, and money. Okay, so we are considering our goals, time and budget, like gathering all the right pieces for our Lego castle. And then let's proceed to this part where we are saying that um a good design is often characterized by flexibility, appropriateness, efficiency, economy, etc. So these are great qualities to know. A good design is like a superhero with flexible powers, appropriate tools, efficient skills, and economic ways to save the day. And a good design is, is like rock star. We are learning about the amazing things a good design can do, like a guitar solo. So first of all, it minimizes bias and maximizes the reliability of the data collected and analyzed. So that's fair and accurate. A good design helps us get unbiased and reliable data, like a referee in a game, ensuring everything is fair and square. It also gives small, less experimental error. So it's about also precision. A good design helps us reduce mistakes and get precise results, like a sharpshooter hitting the bull's eye. And now let's talk about the features of a good design, factors appropriate for consideration in good research design. So we are learning about important factors to consider in good research design. And the first one is the means of obtaining the information. So how do we find the clues? And we think about how to gather information, like searching for hidden treasure, and also the availability and skills of the researcher and his staff, if any. So who's on the team? And we consider who's on our research team and what skills they bring, like assembling a team of superheroes. And the objective of the problem to be studied. What's our quest? And we define what we want to achieve, like setting a goal for our adventure. The nature of the problem to be studied. So what kind of puzzle? The puzzle type. We think about the type of problem we are trying to solve, like figuring out what kind of puzzle we have. And the availability of time for the research work and money. So how much time and gold into brackets, like we are talking about something like budgeting. We plan our time and budget, like allocating time and gold for our adventure. And also important concepts relating to the research design. So we are learning about important concepts in research design, like a music lesson. Concepts relating to research design, we have the dependent and independent variable. What's changing? We learn about variables, which are like changing notes in a song. A concept which can take on different quantitative values is called a variable. So flexible values. Variables can have different values, like different notes on a guitar. Concepts like weight, height, income are all examples of variables. So we see examples of variables like weight, height, and income, which can change like different songs on a playlist. And then we go into discussing the continuous variables phenomena, which can take on quantitatively different values even in decimal points. So these are like precise values, and continuous variables can have precise values, like measuring heights with decimals. And not all variables are continuous. So there are exceptions. Not all variables are continuous. Like some puzzles that don't have decimal answers. And we talk also about non-continuous variables, which are integer values. So these are whole numbers. Non-continuous variables have whole number values like counting toys. And we talk about discrete variables, statistical language for non-continuous variables. So it's like new words. Discrete variables are another name for non-continuous variables, like learning a new vocabulary. Then we talk about this example where age is continuous but the number of children is an example of non-continuous variable. So this is a great example. Like age can be measured precisely, but the number of children is a whole number, like comparing different puzzles. And also, if we say the height that height depends upon age, then height is a dependent variable and age is an independent variable. So this is like relationships. Height and age are connected, like puzzle pieces, and height depends on age. Now let's talk about other important concepts. We have the extraneous uh, variables. We have the extraneous variables where it's like unexpected guests. Extraneous variables are like unexpected visitors that can affect our study, like a surprise party that might distract us. So they are independent variables that are not related to the purpose of the study but might affect the independent variables. So it's like unrelated factors. Extraneous variables are independent factors that aren't part of our study's purpose but can still impact our results, like a surprise rainstorm that might affect our outdoor plan. And we also have the experimental error. So for experimental error, it's like no mistakes. Experimental error is like a mistake in our puzzle that can happen because of extraneous variables, like a puzzle piece that doesn't quite fit, and the effect that is noticed on the dependent variable as a result of extraneous variable. So it's like unexpected changes. Experimental error is when we see changes in our dependent variable because of extraneous variables, like a surprise change in our puzzle picture. And also, a study must always be so designed that the effect upon the dependent variable is attributed entirely to the independent variables and not to some extraneous variable or variables. So it's like precise design. We need to design our study carefully to ensure that our results come from our independent variables, not from extraneous variables, like solving a puzzle with the right pieces. Then we talk about control. So one important characteristic of a good research design is to minimize the influence of extraneous variables. So here we are talking about minimizing distractions. A good research design tries to reduce the impact of extraneous variables, like a puzzle solver avoiding distractions. And the technical term control is used design when we design the study to minimize the effects of extraneous independent variables. So like control techniques, we use control techniques to reduce the influence of extraneous variables, like a puzzle solver using a special tool to fit the pieces together. And then um we are learning about control in research design, like a referee in a game. And also, the technical term control is used when we design the study to minimize the effects of independent variables. So we use controls techniques to reduce the influence of extraneous variables, like a puzzle solver using a special tool to fit puzzles together. And in experimental research, the term control is used to refer to restraint and experimental conditions. So here we are talking about precision conditions. In experiments, control means keeping the conditions precise and consistent, like a scientist controlling a lab experiment. And then we talk about co-founded relationship, which is when co-founded relationship means that our dependent variable is affected by extraneous variables, like a puzzle with mixed up pieces. So when the dependent variable is not free from the influence of extraneous variables, the relationship between the dependent and independent variable is said to be co-founded by an extraneous variable. So it's like clear connections. We want our dependent and independent variables to have a clear connection without interference from extraneous variables, like a puzzle with clear instructions. Then we talk about the research hypothesis. So for the research hypothesis, um we are learning about um like we are learning about research hypothesis, like a detective's clue. And research hypothesis, when a prediction or hypothesized relationship is to be tested by scientific methods. So that for scientific guesses, a research hypothesis is a prediction we test using science, like a puzzle solver's educated guess. It is a predictive statement that relates in independent variables to a dependent variable. So that's like connections. A research hypothesis links an independent variable to a dependent variable, like a puzzle piece connecting two ideas. Then we talk about research. We continue to the research hypothesis, saying that it must contain at least at least it must contain at least one independent and one dependent variable. So it's like a variable duo. A research hypothesis needs at least one independent variable and one dependent variable, like a puzzle with two connected pieces. Then we also talk about predictive statements, which are not to be objectively verified, or the relationships that are assumed but not to be tested are termed research hypothesis. So not a hypothesis. If we can't test or prove it, it is not a research hypothesis, like a puzzle piece that doesn't quite fit. Then we also talk about experimental and non-experimental hypothesis testing. So for experimental and non-experimental hypothesis testing, we talk about research. So we are learning about hypothesis testing, like a puzzle solver strategy. And when the purpose of the research is to test a research hypothesis, it is termed hypothesis testing research. So hypothesis testing research is when we test our predictions, like a puzzle solver checking their answers. It can be of the experimental design or of the non-experimental design. So we can use experimental or non-experimental designs to test our hypothesis, like choosing the right puzzle piece. And research in which the independent variable is manipulated is termed experimental hypothesis testing. So this is like variable control. Experimental research is when we control the independent variable, like a puzzle solver moving pieces around. Also, A research in which an independent variable is not manipulated is called non-experimental hypothesis testing research. So it's like no control. Non-experimental research is when we don't control the independent variable, like a puzzle solver working with fixed pieces. Now we talk about the non-experimental non non-experimental hypothesis testing research. So it's like trying to figure out if two things are connected, like intelligence and reading ability. Also, suppose a researcher wants to study whether intelligence affects reading ability for a group of students. So imagine a researcher who wants to know if being smart helps you read better. And for this purpose, he randomly selects 50 students. So they pick 50 students randomly, like drawing names from your hat, and test their intelligence and reading ability, where they give them tests to see how smart they are and how well they can read. By calculating the coefficient of correlation between the two sets of scores, then they use a special formula to see if there's a connection between the two. The independent variable intelligence is not manipulated, so they are not trying to change how smart the students are, just seeing if it affects their reading ability. Then, so experimental hypothesis testing research, which is like trying to figure out if something works by testing it on a special group. It's like suppose a researcher randomly selects 50 students from a group of students who are to take a course in statistics. So you imagine that a researcher picks 50 students who are about to take a statistics class and then divide them into two groups. So they split them into two teams, like team A and team B, by randomly assigning 25 to group A, the usual studies program, and 25 to group B, the special studies program. So they randomly pick which team each student is on, like flipping a coin. At the end of the course, he administers a test to each group in order to judge the effectiveness of the training program on the students' performance level. So after the course, the researcher gives a test to both teams to see how well they did. In this case, the independent variable, the type of training program, is manipulated. So they are trying to see if the special training program, the independent variable, makes a difference. Then we talk about experimental and control groups. So in experimental hypothesis testing research, when a group is exposed to usual conditions, it is termed a control group. So if a group gets the normal treatment, like the usual studies program, it is called the control group. But when the group is exposed to some novel or special condition, it is called an experimental group. So if a group gets a special treatment, like special studies program, it is called the experimental group. And we talk about treatments. So treatments, let's talk about something we call treatments in research, and the different conditions under which experimental and control groups are put, usually referred to as treatments. So think of treatments like special recipes for your favorite plant, just like how you need different ingredients to make different dishes. Researchers use different treatments to test their ideas. So let's say we want to see which fertilizer makes wheat grow the best. Let's say we want to determine which We want to determine through an experiment the comparative impact of three varieties of fertilizer on the yield of fruit. So we are going to test three different fertilizers to see which one makes the wheat grow the most. In that case, the three varieties of fertilizer will be treated as three treatments. So each fertilizer is like a special treatment for the wheat where, and we are going to see which one works best. Then the process of examining the truth of a statistical hypothesis relating to some research is known as an experiment. So an experiment is like a special test to see if our idea or hypothesis is true or not. And let's say you want to see if a new medicine really works, you can conduct an experiment to examine the usefulness of a certain newly developed drug. That is, we test to see if it's useful or not. And experiments can be of two types: absolute experiments and comparative experiments. And there are two kinds of experiments. One where we test something all by itself, which is absolute, and then another where we compare it to something, which is comparative. Now, here too, we note that let's talk about experimental units. They are predetermined plots or the blocks where different treatments are used. So experimental units are like special areas where we test our treatment, like different fertilizers for plants. Then we talk about categorization of research designs. So let's organize our thinking about research designs. Firstly, research design in case of exploratory studies. So we have exploratory research design, which are like going on a treasure hunt. Then we also have research design in case of descriptive and diagnostic research studies. So we have descriptive and diagnostic research studies, which are like drawing a map to show which areas there, what to show what's already there. Then we also have research design in case of hypothesis testing research studies. And finally, we have hypothesis testing research studies, which are like testing a recipe to see if it works. So research design in case of exploratory studies. Let's dive deeper into exploratory research studies. Exploratory research studies are also termed as formulative research studies. So these studies help us formulate a problem or develop ideas for further investigation. And the main purpose of is to formulate a problem for more precise investigation or to develop the working hypothesis from an operational point of view. So it's like trying to figure out what game to play next. And the major emphasis is on the discovery of ideas and insights. So we are searching for new ideas and insights, like finding hidden treasures. And there are three methods used in context of research design for exploratory studies. We have the survey of concerning literature. We have the literature survey, like searching for clues in a mystery novel. And we also have experience survey, where we have experience survey, which is like asking friends about their favorite games, and the analysis of insights stimulating examples. And finally, we have the analysis of examples that spark new ideas, like finding a hidden puzzle. And then we go to explaining the survey of concerning literature. So it is the most simple and fruitful method of formulating precisely the research problem or developing hypothesis. So this method helps us find the perfect research question or hypothesis, like finding the perfect puzzle piece. Hypotheses stated by earlier workers may be reviewed and their usefulness be evaluated as a basis for further research. So we look at what others have found and see if it helps with our own research, like building on someone's Lego castle, and investigate whether the already stated hypothesis suggests new hypothesis, and we see if their ideas spark new ideas for us, like finding a hidden door in a game. Now let's talk about different research designs, and the first one is a survey of concerning literature. So we are continuing to explore the literature survey. Derive relevant hypotheses in cases where hypotheses have not been formulated. So we can find ideas for hypotheses like discovering a hidden treasure map. The works of current creative writers are also provide a fertile ground for hypothesis formulation. So even creative writers' work can be inspired can inspire research, like finding a puzzle piece in a storybook. Then we talk about experience survey. So let's move on to the experience survey, which means the survey of people who have had practical experience with the problem to be studied. So we ask people who have experience with the problem for insights, like asking a friend who's already played the game for tips. The researcher must prepare an interview schedule for systematic questioning of informants. So we prepare a list of questions to ask them, like a treasure hunt checklist. Then we discuss analysis of insight stimulating examples. So let's explore another method. It's also a fruitful method for suggesting hypotheses for research. So this method helps us find ideas for hypotheses, like finding a puzzle piece that sparks a new idea. So it's particularly stable in areas where there is little experience to serve as a guide. So that means that it's especially helpful when we don't have much information to go on, like navigating a new game without instructions. And this method helps consists of intensive study of selected instances of the phenomenon in which one is interested. So here we deeply study specific examples related to our research question, like examining a fascinating bug under a microscope. Then we talk about research design in case of descriptive and diagnostic research studies. Now, here we are going to move on to descriptive and diagnostic research studies. Descriptive research studies are those studies which are concerned with describing the characteristic of a particular individual or of a group. So descriptive research is like drawing a picture of someone or something, highlighting their features. And diagnostic research studies determine the frequency with which something occurs or as is associated with something else. So diagnostic research is like solving a mystery, finding clues and connections. And examples of diagnostic research studies are studies concerning whether certain variables are associated. So it's like investigating if playing a game is related to having fun, or if reading a book is connected to learning new things. Then we talk about research design in case of descriptive and diagnostic research studies. So let's dive deeper into descriptive and diagnostic research studies. And in descriptive as well as in diagnostic research studies, the researcher must be able to define clearly what he wants to measure. Where the researcher must know exactly what they want to study, like defining the shape of a puzzle piece, and must find adequate methods of measuring it. They need to find the right tools to measure it, like a ruler, to measure a room, along with a clear-cut definition of the population he or she wants to study. And here they must clearly define who or what they want to study, like identifying the players in a game. Also, research design, in case of descriptive and diagnostic research studies, we are also going to say that the research must focus the attention on the following. The researcher must pay attention to the following: formulating the objective of the study, what the study is about and why it is being made. Also, designing the method of data collection, what techniques of gathering data will be adopted. Next, they must plan how to collect data, like choosing the right tools for a treasure hunt. Also, selecting the sample, how much material will be needed. So the researcher chooses the right amount of data by selecting perfect puzzle pieces. Also, collecting the data, where can the required data be found, and what time period should the data be related. So they find the data they need, like searching for hidden treasure in a specific time era. Also, processing and analyzing the data, where they organize and study the data, like solving a mystery with clues, then reporting the findings. Here they finally share their discoveries, like revealing the treasure map's secrets. Then we talk about the difference in research designs. um Difference in research design in respect to explorative or formulative research and descriptive and diagnostic research. Okay, so we are going to compare research designs for different types of research. So exploratory research is like a treasure hunt for new ideas, and descriptive and diagnostic research is like solving mystery, finding clues and connections. So different research designs, like different games, require different strategies. So we have the research design, the exploratory of formulative, and the descriptive diagnostic. So the overall design for and then the type of study, it should be like a flexible design. Design must provide opportunity for considering different aspects of the problem. And for descriptive, it should be like a rigid design, and design must make enough provision for protection against bias and must maximize reliability. Also, sampling design, it is non-probability sampling design, purposive of judgment sampling. So probability sampling design, which is random sampling. We also have statistical design, which is no pre-planned design for analysis, and pre-planned design for analysis. That is for the descriptive or diagnostic. Then we also have observational design for the exploratory or formulative, unstructured instruments for collection of data, and for the descriptive or diagnostic, structured or well thought out instruments for collection of data. And operational design, no fixed decision about the operational procedure. And then under descriptive or diagnostic, advanced decision about operational procedures. Now we proceed to try and discuss research design in case of descriptive and diagnostic research studies. So let's keep exploring research design. The hypothesis testing research design. Hypothesis testing research studies, generally known as experimental studies, are those where the researcher tests the hypothesis of causal relationships between variables. So these studies test if one thing causes another, like seeing if a game piece moves when you push it. Then we talk about how such studies require procedures that will not only introduce bias and increase reliability, but will permit drawing inference about causality. And here they need special steps to ensure accurate results and avoid mistakes, like following a recipe to make a yummy cake. Then we also talk about experimental is credited with Professor Fisher when he was working at Rothamsted Experimental Station Centre of Agriculture in England. So Professor Fisher, a smart man, developed experimental designs while working at a special research centre in England. He enumerated three principles of experimental design. The first one was principle of replication, which is repeating experiments. Principle of randomization, which is mixing up things randomly. And principle of local control, which is controlling the experiment surroundings. And then we go into the principle of replication. Okay, so let's learn about it. The experiment should be repeated more than once. We need to repeat the experiments many times, like playing a game multiple times to ensure we win. Each treatment is applied in many experimental units instead of one. So we apply the treatment to many samples, not just one, like testing a new toy on multiple kids. By doing so, statistical accuracy of the experiment is increased. So this helps us get more accurate results, like getting a better score on a game by practicing more. Principle of randomization. It provides protection when we conduct an experiment against the effects of extraneous factors by randomization. So this principle helps us avoid mistakes by mixing things up randomly, like shuffling a deck of cards. And this principle indicates that we should design or plan the experiment in such a way that the variation caused by extraneous factors can all be combined under general heading of chance. So we design the experiment to include random variations, like rolling a die to ensure fair results. And then we talk about principle of local control. So for the principle of local control is another important principle of experimental design, and the principle helps us control extraneous factors, like turning on the TV to focus on a game. And the principle the extraneous factor under the principle the extraneous factor, the known source of our reliability is made to vary deliberately over as wide a range as necessary. So we deliberately change the extraneous factors, like trying different game levels to see its effects. This needs to be done in such a way that the variability it causes can be measured and hence eliminated from the experimental error. So we measure the effect and remove it from the experimental error, like fixing a mistake in a puzzle. So yes, an experimental design refers to the framework or structure of an experiment. So an experimental design is like a blueprint. An experimental design is like a blueprint, right, for a game guiding how we play. Experimental designs into two broad categories. You have the informal experimental designs and the formal experimental design. So there are two types of designs. The informal is like a casual game, and the formal is like a tournament. Then we talk about informal experimental designs, which are those designs that normally use a less sophisticated form of analysis based on differences in magnitude. So let's learn about the informal designs, right? And these designs use simpler analysis like comparing sizes to see what's different. For formal designs, um they offer relatively more control and use precise statistical procedures for analysis. So formal designs are like precise recipes, giving us more control and using advanced statistics to analyze results. So yeah, and important experiment designs are as follows. So we have the informal experiment designs. First, we have the informal designs like casual games. Then, um, before and after without control design. This design is like a game, then changing. It's like playing a game, then changing something and playing again without a comparison group. After only control design. This design is like playing a game with a friend but only measuring the outcome at the end with a comparison group. Then we have the before and after with control design. So this design is like playing a game, measuring the outcome, changing something, playing a game, and comparing the results with a control group. Then we go to the importance of designs also as follows. Now for B, we have the formal experimental design. So we are going to explore formal experimental design. Completely randomized design, which is the CR design. This design is like a game where players are randomly assigned to teams. Randomized block design. This is like a game where players are divided into teams based on skill level and then randomly assigned to groups. Then we also have the Latin square design, which is like a game where players are arranged in a special grid like a puzzle. Then we have the factorial design, where these designs are like games where we test multiple factors like different game pieces and boards to see how they interact. Then we talk about objectives. So now let's learn about factorial design. Um, Define factorial design. So um, factorial design is like a game where we test multiple factors together. Then we have describe the terms related to factorial design. So we'll learn the special words used in factorial design like factors and interactions. Then we also talk about formulating factorial design. So we'll create our own factorial design like building a game board. Then describe graphically the result of factorial design. So we'll draw pictures to show what we learned from our game, like a graph showing how different factors affected the outcome, and identifying the advantages and limitations of factorial design. So here we will discover good and not so good things about factorial design, like how it helps us understand interactions that can be complex. So meaning of factorial design. So factorial design factorial design is one in which two or more variables or factors are employed in such a way that all the possible combinations of the selected variable of each variables are used. McBurney and White 2007. So factorial design is like a game where we mix and match different ingredients to see how they work. And then we have terms related to factorial design. So factor, the term factor is broadly used to include the independent variable that is manipulated by the investigator in the experiments or that is manipulated through selection. So a factor is like a special ingredient we add to our game to see how it changes the outcome. Think of it like adding different flavors to your favorite dessert to see how they change the taste. Then we talk about factors related to factorial design. The first one is main effect. This is the simplest effect of a factor on a dependent variable. Okay, and a main effect is like a single ingredient special power in a game, and it is the effect of the factor alone averaged across the level of other factors. So we look at how these ingredients affect the outcome without mixing it with others. And according to um, McBurney and White, 2007, main effects in factorial experiment. The effects of one independent variable averaged over all levels of another independent variable. So think of it like seeing how one flavor affects the dessert no matter what other flavors are added. Okay, so um the another term related to, we are continuing the same field. So according to McBurney and White, 2007, interaction means when the effect of one independent variable depends on the levels of another independent variable. So an interaction is like a special combination of ingredients that changes the outcome in our game. Okay, and then we also talk about interaction, an example. So a cholesterol reduction clinic has two diets and one exercise regime. So imagine a clinic with two special menus and fun exercise program. It was found that the exercise alone was effective and the diet alone was effective in reducing cholesterol levels, main effects of exercise and main effect of diet. So the clinic discovered that exercise and diet alone help lower cholesterol. So yeah, when they combined exercise and diet, something special happened. Let's talk about the interaction example. Also, for those patients who didn't exercise, the two diets worked well. The main effect of the diet. So, great news, both diets help patients who didn't exercise, like two different flavors of ice cream that are both yummy. So, those who follow diet A and exercise got benefits of both, main effects of diet A and main effects of exercise. And the patients who follow diet A exercise got a double bonus, like having a scoop of ice cream from a cherry with a cherry on top. And factorial design. So however, it was found that those patients who followed diet B and got exercise got benefits of both plus an interaction. Main effects of diet B, main effects of exercise plus an interaction effect of diet and exercise. But wait, there's more. Patients who followed diet B and exercise got an extra special bonus like finding a golden coin in their ice cream cone. And let's talk about the types of interaction. So we have the antagonistic interaction when main effect is non-significant and interaction is significant. So imagine two superheroes who cancel each other's powers. In this situation, the two independent variables tend to reverse each other's effects, like two opposite forces that neutralize each other. Then we talk about the synergistic interaction, where when higher level of one independent variable enhances the effect of another independent variable. So think of two superheroes who join forces and become unstoppable. When higher level of one independent variable enhances the effect of another independent variable, like a dynamic duo that saves the day. Then we talk about the ceiling effect interaction. When the higher level of one independent variable reduces the differential effect of another variable. So imagine a superhero who limits the power of another superhero. So that one variable has a smaller effect when paired with a higher level of a second variable. So like a superhero that cancels out another power. Terms related to factorial design. So let's talk about randomization. Randomization is a process by which experimental units are allocated to treatment. That is, by a random process and not by any subjective process. So imagine putting different toys in a bag and randomly picking which one to play with. The treatment should be allocated to units in such a way that each treatment is equally likely to be applied to each unit. So like making sure each toy has an equal chance of being chosen. And the term related to factorial design, we have blocking. So blocking is a procedure by which experimental units are grouped into homogeneous clusters in an attempt to improve the comparison of each by randomly allocating the treatment within each cluster or block. And then we talk about so in explanation of this, think of grouping similar toys together like blocks or dolls to make it easier to compare them. Then we also talk about simple two factor design. So let's learn about simple two-factor design. In the two-factor design, we have two independent variables, each of which has two values or levels. Imagine having two different colors of ice cream, each with two different toppings. This is known as 2 by 2 factorial design because of the two levels of each variable. So this is like a special grid with two rows and two columns. Here, each combination of flavors and toppings meets in a delicious way. Then we talk about simple two-factor design. So, for the simple two-factor design, it's um the simple two-factor design. The layout of the factorial design is in such a way that um if we have, as you can see here, this is the diagram of the simple two-factor design, and it's 2 by 2 factorial design. Factor B, then factor A has A1 and A2, so B comes to the A1 B1, then B comes to A2 B1, then B2 comes to A1 B2 and A2 B2. So what they are saying, or what they mean here, is that if we have two levels of one variable and three of another variable, we would have 2 by 3 factorial design. So imagine having two different flavors of ice cream, chocolate and vanilla, and three different toppings, sprinkles, nuts, and caramel, and that's a 2 by 3 design. Then um you talk about 2 by 3 design again, and that one is like a 2 by 3 factorial design. We have, it's like a special grid with two rows, flavors, and three columns, which are the toppings, where each combination meets in a delicious way. So here is an example of a 2 by 3 factorial design where we have factors B and factor A. Factor A is made up of 3, A1, A2, A3, and factor B is made up of B1 and B2. So A, B, A1, B1, B, then A2 B2, then A3 B3, then A1 B2, A2 B2, and A3 B3 B2. Now we are going to try and discuss the experiments. An experiment is being conducted to pyrolyze plastic waste LDPE into fuel or gasoline and diesel. So imagine taking old plastic bottles and turning them into fuel for cars. It is known that catalysts improve production selectivity. So catalysts are like special helpers that make fuel we get the right type of fuel. And another factor, temperature, also affects the product distribution. So temperature is like the heat level in an oven, and it changes how the fuel is made. We want to conduct an experiment to study the effects of these two factors, catalyst types and temperature, on the product distribution, amount of liquid fuel, gas and char. So we want to see how different catalysts and temperatures affect the fuel we get. So we are using the 3x3 factorial design. It's like a special grid with 3 rows and 3 columns. So the 3 rows will be the temperature and the 3 columns will be the catalyst, where we test all possible combinations. So factorial, where we test all possible combinations. So the factors, we have T1, T2, T3. So these are the temperatures, like low temperature, medium and high. And we have C1, C2, C3. So these are the catalysts, like special helpers 1, 2 and 3. And the factorial design is a 3x3 type. And so factorial design using two factors, reaction and type of reaction temperature and type of catalyst. So we are using a 3x3 design to see how temperature and catalyst work together to make the fuel. So yes, and if you see here, it will be T1 C1, T2 C2, T1 C1, T2 C1, T3 C1, T1 C2, T2 and so on. So the advantage of factorial design. So let's learn about the advantage of factorial design. So imagine first of all, the factorial design enables the researcher to manipulate and control two or more independent variables simultaneously. So imagine being able to mix and match different ingredients in a special recipe all at the same time. By this design, we can study the separate and combined effects of number of independent variables. So we can see how each ingredient it affects the outcome and how they work together like a team. And factorial design is more precise than single factor design. Okay, so this means it's like using a special tool that helps us get exact measurements instead of just guessing. And for the advantages of factorial design, we have, by factorial design we can find out the independence or main effects of independent variables and interactive effects of two or more independent variables. So we can discover the special power of each ingredient and how they work together in a special way. And the experimental results of a factorial experiment are more comprehensive and can be generalized to a wider range due to the manipulation of several independent variables is one experiment. So it is like conducting a super experiment that gives us a complete picture and helps understand how things work in many different situations. Now let's talk about the limitations. So the limitations here, we are going to learn about the limitations of factorial design. So when we have more than 3 independent variables, each with 3 or more levels are to be manipulated together, and the experimental setup and statistical analysis become very complicated. So imagine trying to mix too many ingredients in a recipe it gets hard to keep track. In factorial experiments, when the number of treatment combinations or treatments become larger, it becomes difficult for the experimenter to select a homogeneous group. So it's like trying to find a group of friends who are like all the same or who like the same things. It can be tough. So, in summary, factorial designs are employed when one wants to study the independent and joint effect of two or more independent variables. So we use factorial design to see how different ingredients work together, and there are different types of interactions such as antagonistic, synergistic, and ceiling effects. So how some friends work well together and others don't. And factorial design may be conducted as within subject, between subjects, or they may be used in mixed experiments that have one within subject and one between subject. So we can mix and match different ways of experimenting, like trying different recipes. So we have learned about the limitations and summary of factorial design in our game of experimentation.